Okay.
You can just introduce me as Angela. It's fine.
Okay. Yep. We're live now. So, hello everyone, and welcome back to the workshop series for Zion's Believathon, specifically to the mini series on Speedrun Dapp development. I'm James from the DoraHacks operations team. Delighted here to be joined by Angela. How are you doing, Angela?
I'm doing well, thank you.
Thanks for joining. Just a quick overview of the hackathon for anyone that hasn't been up to date with all the past workshops. The Believeathon has 10 days left, and we've got a number of workshops, so make sure you're following our socials to make sure you don't miss any of the workshops that we've got. And today, as I said, Angela's going to be talking about DApp development. This is, I believe, the second episode in this mini series. So without any further ado, Ange, over to you.
Thank you. Oh, give me 1 second. Um, I hope people are joining in, and if you have not already joined yesterday's session, I would highly recommend going through its recording at least when you're starting to set up your environment for this particular session. It's not required that you go over it right now because I'm going to be skimming through the summary of yesterday's session in this video, like right before I start coding. But I would still recommend going over it afterwards. Um, and this would sort of be building up on the contract that we deployed in our last session. I am gonna share my screen quickly. And oh, also, if you guys have any questions, feel free to post it in the chat whenever, and I'll be able to look at the questions in between context switching, in between certain topics. I'm just gonna share my entire screen.
I'll get out of the way and leave you to it.
And here. I was actually just putting this together. So this is the agenda that was shared in the Telegram announcement and in the Discord announcement. I am just gonna remove this. So this is our agenda for today, and this is what we'll be hoping to cover. I'm gonna try to cover most of it. If some of it is left, we are gonna have some videos recorded for you, and I can share them on Discord. This is gonna be the second and the last session of this mini series. And the whole agenda for this mini series, like yesterday and today, was to go through the Dapp development process on Zion. So yesterday, what we did was this is a summary of yesterday's. This is a summary of part one, and I'm just gonna put it here. So yesterday we went over what a blockchain is, sort of thinking of like how to think about a blockchain and what a distributed data structure means, what exactly blocks are. We sort of zoomed in into a block and we discussed that it is basically just a set of transactions all hashed together into another data structure. We looked into what a transaction could be. So a transaction could be a set of multiple execution messages. And we also discussed how transactions are atomic, which means that if the first one goes through, but the second one reverts, the whole transaction reverts. These are some like basic fundamental things to always keep in mind when you're developing on the blockchain. Next, we went over tech stack of a dApp or anatomy of a dApp. And these are the components that your dApp is usually going to have, more or less. So you're going to have depending on how complex the dApp is, you could have multiples of these. Maybe you're interfacing with multiple chains. Maybe you have multiple SDKs interfacing with multiple chains. Maybe there are different kinds of backends. Maybe there are microservices. And in client, maybe you have different clients or different front ends. So depending on how complex the dApp is, you could have this anatomy could grow, but essentially these are what the basic components are. So you'll always have a chain that you're going to pick. And in our case, we are going through this anatomy of a dApp within Zion's context. So if you're developing or deploying your application, you're deploying on Zion. So you have an SDK. So Zion provides an SDK, which is Zion.js. It is a JavaScript interface that talks to the chain on your behalf when you import it into your client. We have a backend. Now this backend is going to be your server. So for example, your Next.js's APIs or your indexer or a database that you've put together. And the client is going to be a React app or a Next.js app. The only reason why I'm sticking with JS and Next.js and React is because Zion currently provides support and SDK just for React and React.js and Next.js. Next.js is just a framework on React.js, so that's the same thing. Because we just have SDK for that. This is why we're going to stick with the tutorial for that. But you can always build your own SDKs. So, for example, if you have a Unity game that you're working on, you can work on your own SDK for it. Or if there's a Rust backend that you have, then you can definitely create your own function calls, because all a chain is doing is responding to your RPC calls. SDK is just a wrapper on top of RPC calls, so you can create your own wrappers for what it's worth. Next, we looked into this was the last and final theoretical concept that we went over yesterday, which was what exactly a chain is. And the way I describe chains here is that thinking of chains as a state machines, and a state machine is basically just a mental model. I like to think in terms of mental models, because it rids you of going through all of the theoretical pointers when you're comparing stuff. So, for example, now that you know, or now that you understand chain is a state machine, you can always compare different chains. So, for example, you can compare Ethereum and Zion, or Solana and Zion, based on how the state machine behaves. And within a state machine, we would have an S1, like an initial state, an S2, the state that S1 wants to go to, and a function of the function that takes S1 as a parameter, basically something that we do based off of S1, which produces S2. So something that we do would always be set of transactions. And this is also called state transition functions. So you could have multiple different ways that this transaction is happening. So you could compare chains based off of this FS1, or you could compare chains based off of this arrow. So this arrow is basically the consensus algorithm. How are the multiple different nodes or the distributed nodes in the chains system agreeing on the state transition function's result? So the agreement, like how S1 actually transforms into S2, is the consensus. And the way it happens through the function, the transition function, is the transactions. So you could call the state machine as a framework governing the system state, and the state transition function as the transaction that's happening. This is just in short of what I just explained. And a state machine is also responsible to ensure that all of the nodes agree on a particular state. Um, this and that's basically it. We should have a basic comparison in our mind when we're dealing with chains, or when we're starting to deploy a dApp, because picking a chain is usually going to be like the biggest question that you're going to have to answer when you're deploying your dApp. Like, why exactly Zion? Why exactly Polygon? Or why Ethereum? And for Zion in particular, we're going to be focusing on the user experience, because that is the USP of Zion chain. Though, because any client that works with SDKs to interact with a chain would always have to do some sort of onboarding for its users, which means that you would always have to have like a whole tutorial or a whole explanation of why users need to approve certain transactions, or why users need to keep their keys on them, or uh, why they need to be onboarded to MetaMask, let's say. Because of this anatomy of a dApp, you always need to have some sort of onboarding on the client side. But the whole USP for Zion is that you could have this whole system without any onboarding. So actually, if I just quickly compare, this is a tech stack of a Web2 application, so to speak. So a Web2 application usually just has this. Now, you might have SDKs that are sitting on the client, interacting with the client, or sitting on the client and interacting with certain external services. But this is essentially what a Web 2 dApp is. There's no chain. There's just a client and a backend, and a server in particular. Let's say this is our server, and that's pretty much it. And because we have a whole chain, also in a dApp, you could also have external servers that the client is interacting with. So this is still possible here. But the point I'm trying to make here is that because we have a whole chain interaction in a dApp, which is a Web3 application, it makes it slightly complicated to have simpler onboarding on the client side, which is why we see all of the problems in onboarding on Web3 dApps. The whole thing with Zion is that I'm just going to delete this. So the whole thing with Zion is that you can essentially make this chain transparent completely, which means that, I could actually represent it as this, and this doesn't even exist as far as the user is concerned, the user that is interacting over here. So if I were to create an interaction here, the user doesn't have to know anything about the chain. However, in any other chain, even in Solana, if any of you guys are coming from a different environment of dApp development, you would know that the user would need to interact with the chain directly at some point of onboarding. And this arrow is what we don't need in terms of Zion. And this is why, we are having this hackathon, and this is why we are having this workshop, because we're going to learn how you can use the SDK to sort of make the chain completely transparent. And that was sort of the first part of this session, where I went over a brief summary of why we are here and what we did yesterday. The agenda for today is going to be, we are going to be picking up the contract that we deployed in our last session, and we're going to be deploying a treasury contract. So this is a step that is essential to Zion, and that is unique to Zion chain. This is something that won't be necessary in any other chain that you're deploying. And the reason it's necessary is, like I just mentioned, to make the chain transparent and to make the UX more seamless. Then we're going to be building our application, and we're going to be using Abstraction SDK to sort of interact with our chain. And we're going to be skimming over some tools. I have already shared one particular tool in our announcements on Discord and Telegram. Feel free to check it out there, but I'm just going to be going over that document once. I can quickly take any questions or any comments if there are any before I head into the session. But seems like we don't have any questions right now. I guess I can keep going. Okay. So so in yesterday's session, we deployed our contract. We deployed the CW721 contract, and we also stored the contract address in our application. And also we spun up a basic Next.js front end for it. So I'm just gonna head into the demo thing that we worked on here. So this is our code base from yesterday. And like I mentioned before, feel free to look into the recording for yesterday if there's anything that you think I'm missing going over. But this was essentially us cloning the CosmWasm standard NFT contracts repository. We went into this repository, we looked into the CW721 base, which is what we'll be requiring to work on our dApp. And we compiled all of the contracts. We formed, like, the artifacts directory was formed, and we got the WASM binary. The WASM binary is what we uploaded on the Zion chain. The uploading command returned a code ID, which is what we used to instantiate our contract. And once we instantiated it, we went into the constants and we sort of pasted our contract address here. We will be going over the deployment part one more time because we want certain changes in the contract address. Um, Actually, we might not have time for that because we are already 17 minutes in. I'm just gonna share a document after this workshop that will help you go over like the parts that I will be skipping in this framework, in this whole DApp setup. But for now, let's just stick with the contract address that we pasted yesterday. So we're gonna start with this, and we're gonna try and interact with the application right now. So the first thing to do when you have just created your application is, well, first make sure that the contract address is set up correctly. Second, we're going to look into our page and we're going to import our abstraction SDK. For that, so this is the layout.tsx and this is the page.tsx. All of the providers always go into layout.tsx when you're working with Next.js. So we're gonna go into our documentation, and it's always nice to keep the documentation handy because it will always have like all of these steps and guides that I have shared in the first session, yesterday's session, and in today's session. So you can always just keep docs.burn.com bookmarked. Here we're actually just following this entire guide today. So you can basically just follow this after the call, after the workshop is done. So we are gonna basically install the abstraction SDK, and this abstraction SDK is gonna help us in the interfacing part. So I'm just gonna put it here so that I can always have it on me. Just gonna put it here. I'm gonna try to, let me just hide this. And yeah, we're good now. So we're just gonna first install the abstraction SDK in our front-end app. It's gonna take a while to install. And once it is installed, what we want to do is import the abstraction provider into our application. So we're just going to do import, abstraction provider from the abstraction SDK that we just installed. And we're going to wrap our entire application in the provider. Here, it's going to error because it is expecting some sort of config. So I'm going to give it a config and I'm going to keep it empty for now. So this config, actually, if you look into the config structure, it actually wants a contract address, a set of contracts actually. And for the contracts, it is expecting address and amounts. And for that, we're gonna first look into the treasury. And give me 1 second. So the contract usually expects something like a treasury and this. Just gonna wrap it here like this. So so what exactly a treasury? What is exactly a treasury? So I'm just gonna go into my Xcali draw again. So we are at this section of our workshop right now. And why exactly do we need a treasury? So like I mentioned over here, if I go back on this particular slide, when the user interacts with the client sort of sends certain function calls to the chain through the SDK. And all of these interactions happen via message executions, which is a transaction. And all of these transactions go into a block in a blockchain. For a transaction to be included in a block, we need to pay some amount of gas. And all of the transactions that a user is doing via the client, a user is supposed to pay gas for any transaction that is happening. But this is where Zion makes it seamless for the user, where the Dapp developer, let's say this is the Dapp developer, can make it so that all of the interactions that happen to the client happen via the treasury. So we are basically deploying something over here. Let's say this is our smart contract, and this is our treasury. A bad representation, but let's say this is what it is. So we're going to be deploying a treasury onto the chain, which sort of which is through which all of the interactions are going to happen for the user, and the treasury is going to take care of paying for the gas fees. So the interaction that happens to the client goes via the SDK, um, and goes via the treasury onto the actual contract. You don't again, this is like a really high level representation of what's actually happening. And as far as Dapp development is concerned, and as far as this workshop is concerned, all we want to do is get to a running Dapp as quickly as possible. So for all intents and purposes in this workshop, you can expect the treasury to sort of take care of gas payment for you. And I'm gonna go back into our slide here. So for the treasury, you're going to go into the developer portal. The developer portal is deployed at dev.testnet.burnt.com. So this is where you want to go, dev.testnet.burnt.com. And for mainnet, it's going to be dev.mainnet.burnt.com. And once you head into here, you're going to click on connect. Because I'm already connected with my account, it just takes me to the homepage directly, but you can always click on connect and enter your email. You'll get a OTP, and you'll be able to deploy your treasury. So developer portal right now just has interactions for the treasury, but soon you can expect other interactions as well here. So this is like a portal for all kinds of developer interactions, and a portal for developers to sort of manage their application. Here you're going to see a few config options, and I'm going to quickly go over what the treasury does. So here, the first thing, so it takes in grants and it deploys a treasury contract based off of the grants that you specify. So for our application, we want to do a basic allowance. And let's say as a Dapp developer, I'm okay with paying up to 1,000 U Zion for each user that is interacting on my application. So that is up to 1,000 U Zion for each transaction by each user. So per transaction per user. So this is something that you should keep in mind. A fee grant is per transaction per user. And you go into basic. For most applications, you should be okay with basic allowance. If you want to do a periodic or allowed message, that is slightly that is like a slightly advanced version of setting up a fee grant config. And you should know why you're doing this if you're getting into the other sort of configs. But for our purposes, let me just do 10 U Zion per transaction and per user. So I'm going to click on encode. It changes the value a bit. And in the description, I can change the description to something like paying 10 U Zion on behalf of the user, or something completely else. But this description should be descriptive of what kind of grant, what kind of authorization you are asking of the user. So I'm just going to add fee grant here. Save fee config. And the next one is the grant config. So this is what takes care of message executions via the treasury. So you always want to make sure that this is accurate, which means that in our case, because we want the interactions to happen on the contract via the treasury. So in my case, it's going to be message execute contract. And this is what it's going to be in most of the cases for most of the dApps that you're deploying. So I'm going to click on contract execution authorization, and contract address is the address that we just deployed. So I'm going to go back here, and I'm going to pick my constants here. Maximum, if you do not know what a maximum calls limit is, or if you're not sure what to put in here, safe bet, just put in 255. And also one of max calls limit or the max funds is required, not both. So you can either do max calls limit, which is 255, or maximum funds required, which would be something like Zion. Maximum funds is, so this parameter represents how many funds to a maximum limit can be sent to the treasury. So for example, when you're sending a transaction, you can send a value in the transaction as well. So in the message execution, you can also send some tokens to the contract as well. So you can either set that here, or you can just set maximum calls limit. So in our case, I'm just going to do maximum calls, and I'm going to allow all messages here. Again, these other two are sort of advanced ways of setting up your config, and you should not get into this, in my opinion, if you're not sure what these means. Accepted message keys is to filter the calls to your contract via the treasury, which means that you can only allow one type of execution, or you can allow only, let's say, two different kinds of users. So for example, if your contract has a function that takes care of deploying new contracts and a function that takes care of changing a variable, and you only want to allow changing a variable, not the deploying new contracts, or you want to sort of restrict access to admin functions, that is where you can use the filtering. And I mistakenly pressed escape, which is why I need to set up my config again. Save config. And in here, yeah, we were in message execute contract, and I was talking about the allowed all messages keys. So I'm just going to do 255. And here, so accepted message keys or accepted raw messages, these are both for filtering. So I'm just going to do allow all, and that is what is relevant for us. You always want to make sure that you click on add, and you can add more contracts if your DApp requires more contracts over here, or if you're interfacing with multiple contracts on the chain. In our case, it's just one, and I'm going to click on encode and save Speedrun config. So this is our fee config, and this is our grant config. And this is what creates our treasury. So I'm just going to click on create. I'm going to look into my console and see what went wrong. Seems like the error is not... Oh, I have insufficient funds. Actually, that should be fine, because how about I change? Let me just connect it again. Log out, connect. Actually, if you're not able to deploy with my currently connected account, we can always pick an existing treasury that I created for the workshop. So for the workshop's purpose, you should be able to follow these steps and deploy your own treasury anyway. And for later, we can get into why exactly this error was coming up. I'm going to do a message execute contract execution. I'm going to set this. Actually, we don't need this. Allowed all messages, add, encode, save, create. Seems like the SDK is not happy with my spendable balance. Let me just see if I can get into my settings. So I do have some use ion already. Let me just open my dev portal here. So I do have a few treasury instances that will help me get started with the deployment. Let me just pick a treasury instance that's available to me. And I'm just going to close this. And I'm going to get back in here. And I'm going to define my treasury over here. So this is a treasury instance that I had from before. For some reason, I'm not able to deploy a new treasury. And that seems to be an issue with my with my account, and possibly that is why the thing is erroring. And I would much rather just try to debug it after the workshop so that it doesn't sort of hinder the flow of the workshop right now. But for now, I'm just gonna pick an already existing treasury and gonna see um, if I can sort of get to the deployment quickly. And I'm just gonna click add. Let me just try it one more time to see if it works. If it doesn't, I'm just gonna use an existing treasury. Yeah, seems like it's erroring somewhere in the grand config. I can look into it later, but for now, let's just close this, and we can head into our application, and we can sort of assume that this is the treasury that we are dealing with. And I am also gonna, because the treasury that I just pasted here interacts with a different contract address that I had sort of set up for testing, I'm just gonna paste that contract address in our contract address over here. So now I'm going to go into layout and I'm going to provide the treasury instance here. So treasury contract address would be the one that we just entered. And that sort of makes our abstraction provider ready to interact with in our Dapp. I'm just going to pause here because there was like a hiccup in the treasury instance. I can take any questions if there are any before I head into the interactions of the SDK with the client. But I can take questions quickly before heading there if there are any questions regarding the treasury. I see some comments, but seems like there aren't any particular questions. I can continue then. I'm just gonna present again. Okay, so we have a treasury instance and we have a contract address that the treasury is sort of dealing with. And we have instantiated our provider over here, and we can now sort of start looking into the interaction. So I'm just gonna put this on the side, and let's see. I'm gonna run my Dapp. And the first thing we're gonna do to check if things are working correctly and if the provider is set up correctly is we're gonna go into the page, and well, first we can look at what it looks like right now. So this is what a local host looks like right now. Ooh, that's a lot of errors. Let me see. Oh, GraphQL. Seems like GraphQL is not installed. So let me just install GraphQL over here. And I'm going to run it again. Let's see. Can't resolve StarkNet. Can't resolve StarkNet. Let's install StarkNet over here. Okay. Hope it's happy now. Let me just npm run dev again. I'm gonna reload. Seems like the webpack imported context is not a function. Oh, this is an error with the webpack. I'm not sure why it is displaying that, because seems like it is not happy with certain it's not happy with certain the version numbers of the application that we're using. So possibly the abstraction SDK that we installed is not compatible with the either React or Next or something relating to it. What we can do, however, is that we can create a fresh instance of a create next app. Let me just head over here and I'm gonna create next app. So so now what I'm doing is sort of doing a fresh installation of Next.js because seems like this installation doesn't have compatible versions in it. I just want to check if it's the version compatibility. So I'm just gonna do this. I could also, so while this installs, let me just quickly see if there's a way that I could debug it. Let me just do this. And let me change my Next.js version to 14 and see if that works. So I'm just going to pick 14.2.13 because that seems to have been working when I tested the Dapp out. I'm just going to do this. This is good now. And for React, I'm gonna do React 18. React. Let's just do 18. And that should be good. I am also gonna just do an npm I again, just for a clean installation. And I'm gonna try running the app again. Oh, next is, yeah, it was possibly a version thing. So I'm just going to go into my freshly installed application right now. And this is also something that I would recommend doing. In the last, so I'm just going to share the issue here. So in the last session, we went into the setting up project and we set up our project using this function with certain configs that we entered here, and seems like that those configs were not entirely happy with our abstraction SDK. I can also maybe, so one last thing that I want to try here before sort of losing all hopes and doing a fresh installation is that I could try to see if version 50 works better with my thing. So I'm just gonna do this at 1.0.0 alpha 50. Okay, so let's see. I wonder why it's unhappy with my installation. So for this, it is expecting it to be an MJS. Let me just give it an MJS. So next config MJS, and I'm just gonna change this to this. Let's see. Next.config. Next.config.mjs is installed. Oh, hold on. Let me just see if it's a node issue because we're using node 18 over here. Let me just go into node 14. So Node version is not the issue because Next.js expects. Um. Oh my God, I'm sorry. This was the fresh installation. Let me just delete this. And let me just give this an MJS. All right. So the error there was that because I just created a fresh installation of the Next.js app, I mistakenly changed my next config over there. So I was just in a different directory. And now if I do this, oh, seems like the app broke again. It is not happy with the React DOM versions. So let me just upgrade. Sorry. So React DOM needs to be 18 too. And I'm just going to do npm I React DOM at 18 because we changed a few versions to make sure everything was compatible with each other. I changed React to 18 and forgot to change React DOM, which is why it threw an error. And let's see. It is still unhappy with my Webpack. I wonder why. It's not a function. Create context is not a function. This seems like the issue is coming from here. Let me just do this and see if the issue is actually in the provider. So the problem is in the provider. Let me see. So possibly I made some mistake in installing the provider. Let me try doing the latest install now. So if I do abstraction latest and okay. So seems like the oh no, but I just did a latest install. Let me just try importing it again. That didn't tell us anything. This should be able to tell us a bit more about what the issue is. Seems like it is still the provider. I'm gonna look into my packages and see if there's something I could change in my layout. Seems to be fine. Not sure why this would come up. Seems to be a type error. If I go into my TS config and sort of see. And let me just change this. That is such that is an annoying error that I'm not sure how to resolve, given that everything is supposed to be working correctly here. What I'm going to do is maybe I'll just quickly switch up to an example application that I already have deployed, and we can sort of head into the workings of that. And maybe through the explanation, I'll eventually figure out what's happening here, but I'm not entirely sure why Webpack or why the types are unhappy with create context. Um, this could possibly be in the way abstraction is being inherited into the layout, but I'm just gonna quickly switch it up to this application. So this is an example application that is working in the exact same way as we set up our application just now. And it's called Potato App, and it's also deployed. So this is the repository for this. I've shared a few times in the Believeathon chat, and you should be able to pick it up from there. And I am gonna try and run this app to see if the problem persists. I'm just gonna go here. So it seems like this is happy. And in this application, we are using the same sort of config and the package.json. So it seems like there's something, so I probably have a blind spot in terms of the project setup that I did with the previous one that I'm not sure exactly why it's not working there, but it's sort of working here. So we have these dependencies installed and we have these dev dependencies in the application that I just ran. I would recommend cloning this application and sort of going forward from there. And I'm going to share the instructions in the chat after I'm done with the workshop. So I'm just going to close this for now. Maybe just put it here. And we can now go over this application, which is essentially the exact same thing that we were going to do anyway. So we have CWNFTs, we have the contracts in here that were deployed, and we are now going to interface with the contracts in the web app. This repository also has all of the setup already done, which means that the treasury is already set up for us and the contracts are already set up. If you want to clone this repository right now, if you're following along, you can do something like gh repo clone probably and /potato. So this is the command that you can run. That's my account, and that's the Potato app. This is the Potato app that I'm just working on. I'm gonna head into my layout to sort of go over what's happening here. So this is what we were trying to do in the application. We weren't able to do it, but we're just gonna piggyback off of this already running application to make sure things work fine. In the page.tsx, you're gonna see a lot of things that are happening. So I'm just gonna fold everything and go over the main default page for now. So the first thing we are going to do or go over is using the abstraction account to have some data that we can display, which is like the currently connected account's address, and if the currently connected account is connected or is connecting. We also have a use modal hook, which sort of shows the login page. And let me just go over that. So this is what it looks like. This is the connect button, and these are all of the other helper buttons that this application has for you. We are just going to go into connect for now. So it takes us to the settings page, and it asks, so this is the permission that we set in our treasury. So if you remember when we were setting our treasury, this is the config that we set, and we're going to click on allow and continue, and it should allow us the permission to do stuff. So when the permissions are allowed, what essentially is happening is that currently connected user's account sort of grants certain function calls to the treasury, which means that the treasury is now allowed to perform actions on behalf of the user. Even though the treasury is performing actions on behalf of the user and the treasury is paying gas on behalf of the user, it is not. So when you see the transaction actually happen on chain, the only place where you'll be able to see treasury is in the grantor. The treasury is not going to be sending the transaction. So the sender is still going to be my account address. And this is something that we'll go over quickly before wrapping up and before keeping some time for questions. And I know this was sort of a chaotic workshop, given that so many things broke at just the last moment. But I can assure you that if you follow along with the web app that I just shared, basically this Potato app, and sort of do a clone of this application and sort of build off of it, you should be able to set up the abstraction SDK correctly. I think I made a mistake in setting up some versions, some incompatible versions in my last application. So this should work correctly. And I'm gonna just quickly do a reset here. And what this application is showing me right now is my connected account address, like my Meta account, the potato contract, which is the NFT that we deployed. The ID is the current ID of the NFT that we're gonna mint, and this is just coming from a constant. So I can actually just change it to anything else. Let me just call it this ID, and so this is the potato ID that I can currently mint. And let me just do a quick reset. So owner undefined means that this potato hasn't been minted yet. I can click on view account. So this is my account, and I can read the minter. So minter is the address that is allowed to do the mints. All of this, so whatever I'm talking about right now, so minter, it comes from the contract. So this is just a contract read that's happening. And I'm going to go over the code that will allow you to read the contract and write to the contract. I'm just going to quickly go over the interactions first. So read contract info. This is the entire contract info. Read minter is the minter that is allowed to mint, and that is me, my account. So I should be able to mint, and I'm going to read contract address. So all of these are the contract owners, which means that all of these people have a potato in their account right now. Before going into the execute mint, I want to go into the code for the reading and writing of the smart contract. So these are two helper functions that you will see already written for you in the application. And what these helper functions are doing is they take a client and they take the message and the sender and the contract for the write. So basically the contract that you want to send the message execution to, and on behalf of whom are you sending the execution. So I'm going to do a client execute and just the standard function call. So if you look into the execute function definition, you'll be able to see all of the parameters that it expects. Feel free to put auto in the face, and that's pretty much it. So I can, so for in this helper function, it is already doing all of it for you. And so it is sending it on behalf of a certain user. The contract address, the message is just the memo. So this can, so message is not the memo, sorry. Message is the contract execution message, which is going to be like the function call that you want to call. And this is the fee config. So if I go into the write function again, and if I go into execute into the standard fee, so the standard fee is an object that expects amount, gas, grantor, and payer. So for our purposes, we can ignore the payer, but the grantor is what we want to assign if we want to interface via the treasury. So you always want to have a grantor here, which is the treasury contract. So by doing this, you are allowing the treasury to be invoked and be invoked on behalf of the sender. And this was the write function. And similarly for read function, we're just doing a client query smart contract, and it takes contract as a parameter. You can see here, it takes contract address as the parameter and the query message. So this is pretty standard. And when we were reading the minter, for example, this read minter, we are basically executing a read function with this message. So execute is another helper function that you'll already see in the repository that you're going to clone. And it is going to have, so it's going to take either a read or a write as the first parameter, and it's going to invoke the two functions that I just talked about, the write and read, based off of what you want to do. And it will take the contract address, and it'll basically just either write on the chain or either it'll read from the chain, and it has some basic error handling as well. So these are all of the helper functions that are going to help you. And in terms of reading, this is what we were doing. We were basically passing this message to the contract, like reading the minter. And when we were reading contract info, we were basically passing this message. So you want to make sure that you know the message that you're going to try to call. And over here, you're going to see all accounts. So this is the message that I'm passing to query all of the accounts from the contract that own a particular potato or the NFT. Here I'm just starting after. So this is just pagination. So if I remove this, it's just going to start from the beginning and it's going to return 30 contract addresses. And that's pretty much it in terms of reading. So when I write to the smart contract, I am invoking the similar execute call, and with a message execution message that says mint. The token ID I'm providing is the constant that we just went over. Owner is going to be my address, which is like the currently logged in user. And that's it. So this is what I'm trying to send to the execute call, and the execute is just gonna, this is a helper function, like I said, it's just gonna call write, and it's gonna make sure that the contract goes via the treasury. So I'm just gonna quickly try to execute a mint here, and seems like the transaction couldn't be parsed because Cosmosm contract, query Cosmosm contract failed. Let me see why this is happening. Read contract info. So seems like get potato owner. So 99 is where the error came from. Oh, it's not able to read, which is expected. Transaction failed over here. Oh, so it is possibly like the encoding that I'm doing here. So let me just see why. It is possibly not able to take point here. I should be able to just do something like this and see if that is the issue. If this is the issue, then we just need to figure out a better encoding for 0.0001. Just gonna reload. That's a lot of gas that we're going to be paying, by the way, in the amount. But I just want to see if it's the encoding that's failing. So read minter is fine. Read contract. I'm just going to try to execute. And that's good. So we were able to execute, and this is, so the current potato ID's owner is me. I just executed the smart contract call, and here's the entire transaction result. So I'm just going to take the transaction hash, and I'm going to head into the Explorer. I want to go into testnet. Now I want to paste this here, click confirm, and we can, so even though I sent like one use ion, it was a huge amount of gas, but it just used up this amount of Zion. The only issue, I guess, was in the encoding, and that's it. So this is a transaction hash that is now a success. So we can see the fees is 0.001, a few cents, less than a few cents. This is the message that was executed, and you can see the grantee is our contract address. So if you look into our constants here, CVMJN, and grantee is the sender, and our CVMJN should be in the grantor somewhere. So I'm just gonna, oh yeah, there we go. So grantor is the treasury contract address, and I am gonna go here, my account address. Let me see where exactly my account address is shown. Over here. So sender is my account. My contract is the contract that I specified over here, potato contract. So I'm just gonna look it up. So that's the potato contract. The sender is still the user. So the sender is not the treasury. Treasury is only the grantor. And all the grantor is doing is sort of paying for the fee amount. And this is something that we encoded. And you can see all of the messages that were executed in it. And because there was just one message, you'll be able to see that this is what happened. So if you look into the messages array, you're going to see this is what was executed. This is the contract. No funds were sent, which is good, which wasn't even expected. And that's pretty much it. So we basically deployed, well, quite chaotically, in this session. We sort of deployed the contract, and we sort of tried to interact with the contract. There were a lot of hiccups, and I guess that's the curse of online demos, that there always happens a hiccup, which would there would always be an error that you won't be able to solve in just the right time. But I'm sure I'll be able to figure it out, and I'll be sharing exactly what the issue was if any of you guys were following along. If you are interested in cloning the application, like I said, you can just do gh repo clone. Oh, sorry, and potato. This is the repository that you can clone, and you should be able to get your application up and running. And that's pretty much it. So the only thing that I would recommend keeping in mind is the treasury contracts, and making sure that the treasury is deployed and is interacting with the contract. And I'd be happy to answer any questions while you are developing, if you end up with any issues anywhere. And I can take up any questions right now as well. Seems like there aren't many questions. I'm just going to wait for a few more seconds before we can, I guess, end the stream. Oh, hello. Hi.
Hey, I'm back. Yeah, let's give them a few seconds to see if anyone has any questions. I know sometimes people are watching this not live. They'll be watching on catch up, so then they'll be going through other channels. So obviously you can reach out to Zion through all the links we put in the previous videos and this one. If you have questions for DoraHacks, feel free to ask us and we'll pass it to the relevant people as well. Thanks, Ange, for the workshop today, and unlucky with a few technical issues, but I think everyone got what they needed from it.
Oh my God, there were so many issues. I hope I didn't end up confusing people more than resolving issues, but I'm gonna share some resources and maybe record like a better video for this for the Believeathon hackers. Because seems like I ran into version controlling or some Webpack issues that I haven't been able to resolve yet. But I should be able to send some notes over on Discord or Telegram that should help in sort of setting everything up.
Cool. Yeah, that sounds good. I think it looks like we haven't got any more questions like from the live audience, but if you send those over, then people can check them out in their own time.
Okay, awesome. Sounds good.
Nice. Well, thanks for your time today, and thanks everyone for tuning in.
Thank you.
Okay. Thanks everyone. Till next time.